Hey everyone, today we're diving into something super important for pretty much any electronics project. How do you make your device actually remember things? We're going to explore the world of storage and file systems to figure out how we can keep our data safe and sound even when the power goes out.
So think about this for a second. It's a really simple question, right? But the answer is everything. If your data just vanishes, you're using what's called volatile memory. Think of your computer's RAM. But what if you're building a sensor logger and you need that data to stick around? Well, that's where non-volatile storage comes into play. And that's exactly what we're focused on today.
All right, so first things first. Before we can even think about organizing our data, we need a place to actually put it. Let's talk about the physical hardware, the chips and cards themselves. This is the foundation, and believe me, choosing the right one is a critical first step.
As you can see, you've got a whole menu of options, and each one has a very specific job. Your main program, the firmware, that usually lives right on the chip in internal flash. For those tiny but crucial settings, like a Wi-Fi password or a calibration value, EEPROM is your best friend. Now, if you need to log tons of data, an SD card is the obvious choice. And RAM? Well, that's our super fast but forgetful scratch pad for all the temporary stuff.
Okay, let's zoom in on the two most common types you'll find right on your microcontroller, flash and EEPROM. Here's the classic trade-off you're always going to face. Flash gives you a good amount of space, but it has a limited write endurance. You can only write to the same spot maybe 10,000 times before it wears out. EEPROM, on the other hand, is tiny, but it's an absolute tank. It can handle millions of writes. This is exactly why your firmware, which you write once, goes in flash, but settings that change often are perfect for EEPROM.
So, we've picked our physical storage. Awesome. But a raw chunk of memory, well, it's pretty useless on its own. It's like having a giant empty warehouse with no shelves, no labels, no system at all. We need a way to organize all that chaos, and that system is called a file system.
You know what? This analogy is absolutely perfect. Can you imagine trying to find one specific book in a massive library without a card catalog? It would be impossible. A file system does exactly that for our data, creating a neat structure of files and folders so the computer knows precisely where everything is.
So if we want to get a little more formal about it, a file system is basically the set of rules and the behind-the-scenes data structures that an operating system uses to keep track of everything. It's the magic that translates a simple command like open my log file into the really complex physical operations of reading the right ones and zeros from the memory chip.
And just like you have different types of storage hardware, you have different file systems for different jobs. FAT32 is kind of the universal language for SD cards and USB drives because pretty much any device can read it. For a more powerful device running Linux, like a Raspberry Pi, ext4 is the standard because its journaling feature is a lifesaver, protecting you from data corruption if the power suddenly cuts out. And for writing directly to a microcontroller's internal flash, something like LittleFS is brilliant because it's designed from the ground up to protect that flash from wearing out.
There's one more little piece of jargon we gotta cover here. Mounting. When you plug in an SD card, the system doesn't instantly know what's on it. Mounting is the process of telling the operating system, hey, this storage thing exists and I want you to make its contents available right here. It's basically like unlocking the library doors in the morning and saying, we're open for business.
Okay, so we've got our physical storage and we have a system to organize it. But there's a huge third piece to this puzzle, and honestly, it might be the most important one: reliability. How do we make sure our data stays safe and that our hardware actually lasts as long as possible?
Remember this number? Yeah, this is a big deal. It's the Achilles heel of flash memory. Every single time you write to a memory cell, you cause a tiny amount of physical damage. Do it enough times, say around 10,000, and that cell just stops working. If you're not careful and you keep writing data to the exact same spot, you could brick your device way faster than you'd think.
So what's the fix? Well, it's a really clever technique called wear leveling. Instead of hammering the same physical spot over and over, the system is smart enough to spread the writes out across all the available memory cells. It's just like rotating the tires on your car. You do it to make sure they all wear down evenly. This one trick can dramatically, and I mean dramatically, extend the life of your storage.
So what can you do about it? Well, the key is to be smart from the get-go. If you're writing to internal flash, always use a file system that has wear leveling built right in, like LittleFS. Another fantastic strategy is to buffer your writes. Just collect a bunch of data in RAM first and then write it to the flash in one larger, less frequent chunk. And of course, to guard against corrupted data, you can use checksums. And for those projects that might just lose power, a journaling file system is an absolute lifesaver. All right, theory's great and all, but let's see how all these pieces click together in a real-world project. Let's build a classic, a simple sensor data logger. The logic here is actually pretty simple and straightforward. First, you grab the data from your sensor. Then, just like we talked about, you might buffer a few of those readings in RAM to avoid writing to your storage constantly. Next, you open up a file on, say, an SD card. You write your new data, and here's the key, you append it, so you don't erase your old logs. Then you just close the file and repeat the whole process. It's simple, it's robust, and it uses everything we've talked about.
And this is pretty much what it looks like in the real world. You don't need to be a coding wizard to see what's happening. This little snippet from an ESP32 project does exactly what we described. It opens a file called log.txt in append mode. That's what that file append part does. If that works, it prints a new line of data, and then it closes the file. Clean, simple, and effective.
So let's wrap this all up. If you're going to remember just 3 things from this, let them be these. First, match your hardware to your task. Don't use delicate flash for data that changes all the time. Second, always use a file system. It handles all the heavy lifting of organization and can even protect your hardware. And finally, think about reliability from day one. Buffering your writes and using wear leveling aren't just nice-to-haves, they are absolutely essential for building a device that's going to last.
We've covered the hardware, the organization, and the strategies to make it all last. All the building blocks are right here. So I'll just leave you with this one question. Now that you know how to give your projects a memory, what incredible thing are you going to build?
Hey, I really hope you found this deep dive into storage and file systems useful. If you did, do me a huge favor and hit that like button. Share it with a friend who might find it helpful, and of course, subscribe for more explainers on all things embedded systems. Thanks so much for watching.